Hello, and welcome to the third video on the novel fire debris application called Fire Debris Application Example. My name is Michelle Corbally, and I will be narrating this video. This presentation will show an example of running a fire debris sample using the novel fire debris application. First, select Compound Analysis to load a sample of your own or to view fire debris samples from the NCFS Fire Debris Database. Our example is from the NCFS Fire Debris Database, so click on the small box next to Click to run a fire debris sample from NCFS. I will select RN220 from the drop-down list. You will notice we have removed the class designation from the sample name in later versions. I've selected to view the total ion chromatogram. The top plot is the tick of the fire debris sample, and in the bottom, the compounds that have been identified. The results in the compound list indicate 5 possible identifications for peak number 1, which has a retention index of 481.953. Possible compounds are acetonitrile, 2-methylbutane, acetone, propanol, and N-pentane. All of these compounds meet the requirement of plus or minus 50 retention indices and a spectral match with a Pearson correlation greater than 0.985. The retention index and correlation for each potential compound is provided for the analyst to decide on the compound identification. As you can see here, there were 193 peaks detected in this fire debris sample, and 60 of them were identified as shown in the plot. Here is the plot of the alkanes with identified compounds plotted below. Based on the pattern and compound identifications, I found an area of interest between C5 and around C10. Here is the zoomed area of interest with compounds of that area identified. Compounds identified are branched and normal alkanes. Here is the plot of aromatics with identified compounds plotted below. Based on the pattern and compound identifications, I have found an area of interest between C7 and around C10. Here is the zoomed area of interest with compounds of that area identified. The compounds are single, double, and triple substituted alkyl benzenes. Here is the plot of cycloalkanes and alkenes with identified compounds plotted below. Based on the pattern and compound identifications, I found an area of interest between C5 and around C10. Here is the zoomed area of interest with compounds of that area identified. Most of the compounds identified are branched or cyclic alkanes. Here is the plot of the polynuclear aromatics with identified compounds plotted below. Identified compounds are from pyrolysis products, including naphthalene. Here is the plot of the alcohols and ketones with identified compounds plotted below. The only oxygenated compound identified is potentially acetone. A summary of information obtained through the compound analysis indicates that there is an area between C5 to C10 containing normal alkanes, branched alkanes, cycloalkanes, and aromatics. There is potentially a light petroleum distillate, or LPD, with aromatic ignitable liquid in this fire debris sample. The next step is to find a similar reference ignitable liquid from the ILRC database. Select ILRC Reference to compare the fire debris sample to an ignitable liquid in the ILRC database. I didn't find an LPD/aromatic that was comparable to the fire debris sample in the ILRC database. However, there were several comparable LPDs in the ILRC database, so I will select light petroleum distillate from the ASTM classes. Only ignitable liquids of the LPD class in the ILRC database will be available in the drop-down list. I compared the total ion chromatogram of multiple light petroleum distillates to the fire debris chromatogram. One potential reference LPD is SRN-126. Here is a comparison of the total ion chromatogram of the fire debris sample to the total ion chromatogram of SRN-126. Another potential reference light petroleum distillate is SRN-952. Here is a comparison of the total ion chromatogram of the fire debris sample to SRN-952. Here is a zoomed-in image of the total ion chromatogram for the fire debris sample and SRN-952 between N-pentane and N-nonane. There are 10 compounds in common between the fire debris sample and SRN 952. There is a possibility that aromatics identified between N-nonane and N-decane are pyrolysis products. Here is a zoomed-in image of the alkane extracted ion profile for the fire debris sample and the alkane extracted ion profile for SRN 952 between N-pentane and N-nonane. Next is a zoomed-in image of the aromatic extracted ion profile for the fire debris sample compared to the aromatic extracted ion profile of SRN 952 between N-hexane and N-decane. Here is an image of the indane EIP for the fire debris sample and SRN 952. Next is an image of the cycloalkanes/alkenes EIP for the fire debris sample and SRN 952 between N-pentane and N-nonane. Here is an image of the polynuclear aromatics EIP for the fire debris sample and SRN 952 between N-heptane and N-decane. So in summary, two potential ignitable liquids, which were both light petroleum distillates, were compared to the fire debris sample. There weren't any comparable LPD/aromatic reference ignitable liquids in the database to compare to the fire debris sample. Thank you for your time. For more information on the novel fire debris application, as written by the contributing authors on this slide, please click on the links in the description below.